Okay, now we're over here in Matlab and let's create a script. So I'm going to go New Script. And this new script we will call discrete model 1 variable. Okay, and I'm going to put the title right there as the first line of my comment section. And let's make a few other notes here. This simulation mimics the code presented in Sayama section 4.3. So he uses Python. We'll change some of the things. We're using Matlab. And the model looks like x of t equals a times x of t minus 1. Okay, and I think it's really nice to just put a separator there to end your comment section. And let's save our model as we go. So I'm going to copy discrete model 1 variable. I'm going to save as. Notice that this is saving as an M file. Notice that it's saving in my Math 195 Matlab directory, and that is my current working directory. Okay. All right, so let's get started. The first thing we want to do is we want to initialize all our variables. So we'll set a equal to 1.1. I'm going to suppress the output with a semicolon. We also need to define that x is an array, and we'll do this with the zeros command. So what this does is this says x is an array filled with zeros, and the size is 1 row by 100 columns. Let's just take a look at that code. I'm going to copy paste it to the command window just to look inside. What does that do? And sure enough, that made an array for us. It's quite big. It's 1 row by 100 columns. Everything is set to 0, so we've initialized that. And you can also see that showing up in your workspace over here. You've got variable x, or actually array x is the type of data structure that is, and it's 1 row by 100 columns. Okay, let's run our simulation. So for the simulation, we need to start off with an initial amount of x. So let's say when time equals 1, suppose we start off with 2 individuals. Okay. So this is the initial amount for x at time t equals 1. All right, so now we need to generate values for x at time equals 2, 3, 4, all the way up to 100. So we'll create a for loop for t equals 2 to 100. Keep in mind we're starting at 2 because we already know what the value at 1 is. So we don't need to do that. That's given or decided upon. Now we'll iterate forward from there. Our model looks like x of t equals a times x of t minus 1. Let's end the for loop. And let's give it a whirl. Let's see how our code does. I'm going to save our code. Okay, so let's run the code. So to run the code, we type in or copy paste that name. I'm going to clear everything. So let's run the code, and we didn't get any error messages, so that's good. Let's take a look at what happened. A is set to a value of 1.1, and you can also check that right here. You could say, what is A? Oh, it's 1.1. That's good. That's what we wanted. T is a value 100, so after we've run this code, t looped through for t equals 2 to 100, so the last value that t was is just 100. And then x is an array. Let's take a look at what x looks like. It's got 100 columns, and we've got all sorts of values in there. Okay, and we could take a look at any given value like x at time equals 45. We could take a look at that value. Okay, so let's plot our data. Now I'm going to play around in the command window here just to get our plot looking nice, and once I'm happy, I'll put that right up there in the script. So let's plot. On the horizontal axis, we'll plot 1 to 100. And for the vertical axis, we'll plot x. Okay, that's a decent plot. Now, some things I would like to add to this plot. I'd like that line to be bolder so we can see it better. So I'm going to make this a solid line. I'm going to color it blue, and I'm going to add in line width. Let's make it line width 3. Beautiful. Let's also add some x-axis and y-axis labels. So I'll copy paste this plot right up into our script, so we've got that. To add an x-axis label, we'll go x label, and I'll label this time steps, or just t perhaps. And for the y label, this is our variable that we're modeling. This is x of t. Okay, let's save and clear everything. We'll run the code again. Our plot looks beautiful. We do see the axis labels. The line looks great. And you can change a lot of features here. You can make it a dashed line, for example. But you can go up here and save as. A lot of different options for saving this. You could save it as a Matlab figure file, which allows you to edit it in the future. But if you're going to write a paper or something, it's good to save it as a JPEG or maybe PNG or PDF file, something like that.